frequency problem, open the lock. So it says that you are given a lock in front of you which has 4 circular wheels. In the same way you have your lock in your suitcases, and each wheel have 10 slots, and we also know that each wheel, as if you remember, each wheel have 10 slots, 1 2 3 sorry 0 to 9, and each slot, basically I can just say, okay, that on the each circular wheel, imagine this as like this, 4 digits you have, and on each of them you can place any of them from 0 to 9, 0 to 9, 0 to 9, 0 to 9, and that's how a combination lock works, right? Okay, now each move consists of turning one wheel one slot, and if you had remembered, whenever you have a wheel, let's say like this, then all these wheels individually you can move, right? So if the number, let's say, is 1 here, so maybe you can move it clockwise or anti-clockwise. If you move it, let's say, clockwise, it goes to 2. If you move it anti-clockwise, that 1 would have gone to 0. So that's how one movement is designed here. And initially the lock starts from 0 0 0 0. By default, if you have seen, the factory reset comes in at 0 0 0 0, and that's what they're also saying. Now, apart from these things which are given, they're also giving us a few things. We have a list of dead ends, which means as soon as the lock reaches that specific combination, let's say my combination is 4 3 6 2, let's say this is one of the dead ends. If my lock reaches this specific dead end, it cannot neither come back nor go forward, which means this is done. My lock is jammed. My lock is now jammed, so I cannot make this combination reach one of these dead ends. Even if it reaches, okay, I'm done. I cannot go like after it or before it. That's what it is saying. And also we have given a target, which is what we have to achieve, which combination. Let's say I want to achieve 7 7 7 7. This is what I want to achieve. So this is my target. So I have to tell the minimum total number of turns required to open the lock. And for sure I can open the lock only and only when I reach the target, or they are saying -1 if it is not even possible to reach your target, which is so that you open your actual lock itself. Now, very easily, we don't understand so far that what actual stuff is going to be applied here, right? That's very obvious. If that's the case, start actually building what will happen at every turn, because you remember I told you at every turn what is happening is, okay, let's say you have a number, let's say if I have a number 4 3 2 1, or let's say 4 3 2 6. I have, let's say, current state of lock is this. In one turn I can choose any of these places, and let's say if I tried, okay, I'll try again. I have to try for all the places. Let's say I tried this place, then my task is either I can turn it clockwise, again that's one turn, or maybe I can turn it anti-clockwise, that's another turn. So if I turn it clockwise, I'll get a 4, anti-clockwise I'll get a 2. So this is how a different combination will look like, and thus I can just every turn I can keep on trying and make sure you wanted minimum number of turns. Now let's see. So there's the picture revolves around the turning, which means turning right, turning left, and as soon as I do one turn, either left or right, it is called as one turn itself. So we realize that our initial state will look like a 0 0 0 0. Now if I tell you, okay bro, I'll give you one turn, it is your first turn. Now I ask you, what are all the possible answers? Because see, we are just a dry running, we are just trying to see that what are all the options. So we realize, okay, as soon as I do a one turn, either I can move this, move this, move this, or move this. And as I move, I can either turn it right or left. That's up to me. So what I'll do, okay, I'll move the first one. I'll move the first one to the right. Maybe the second one to the right. Again, this is one turn. Third one to the right. Fourth one to the right. Or maybe first one to the left. And as you know that if I have a 0, it moves to right, okay, goes to 1. If it moves to left, it goes to 9. Right? Because it is circular. Okay, same way, if I move the second one to the left, 9, third one to the left, 9, fourth one to the left, 9. So in one turn, I can just choose any of the 4 digits. So you realize in one turn, I can choose any of the 4 digits, and for all the 4 places or digits, I have 2 options. Either I'll turn it right or left. two options. So you can easily see I will have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 possible options in first turn itself. But make sure that as soon as, because it is possible that one of them is dead end. If one of them is dead end, then you cannot go any further from here. If maybe one of them is target, then you can say, okay, I was able to achieve my target in just one turns. So what you are doing, you are trying for all the possibilities. Same way, let's say if I am here, I will again try for all the possibilities. Again, possibilities are I can change any of the 4 digits, and when I say I'll change it, I'll either turn right or left. Same way, let's try it. Okay, I'll turn the first one right, I'll turn the next one right, I'll turn the next one right, I'll turn the next one right. So okay, I will try for all the 4 options and I'm turning them right. Same way, okay, let's choose the first one and let's turn it left. Let's choose the next one, turn it left. Next one, turn it left. Next one, turn it left. Oh, Aryan, I reached back to a 0, 0, 0, 0, and this is from where I started itself. Okay, so not only I should actually make sure that whosoever, again remember, whosoever is your dead ends, for sure I will make sure whosoever is my dead end, I should never go further beyond them. That's one thing I will make sure. I'll also make sure that there is a chance I'm turning things right and left. So there's a chance that I can come back to the same combination. And if I will keep on trying my entire tree like this, because see, as you can simply see, it's the possible combinations. So it can be a tree. Again, this tree kind of structure we also make while making the DP thing also. So yeah, right now we are just seeing that this kind of structure, it can end up repeating. So make sure that you either take visited, again I'm just showing you the possibility, either you take visited, or you can take, okay Aryan, I can see it's a repeating sub problem, then maybe I can store the answer for them. Again, I'm just showing you what you can think of. I'm not saying it is actually a DP problem. I'm just saying, okay, you can think of, okay Aryan, I can see it's a repeating sub problem, but maybe I can store the answer for it. Okay, now I'll ask you, firstly we'll go on to the repeating sub problem part later on, but I'll ask that firstly you'll make sure that you will not visit this again. No, if you get it on, okay, I have, let's say, seen this 0, 0, 0, 0, I'll stop because I have already computed the answer from here, because ultimately my aim is to reach my target. As soon as, and I know that I am traversing on each turn, which means again for my turn I have 8 options, 4 digits, turning left or right, 8 options I have. So for every turn I am trying all the 8 options, next turn all the 8 options, and so on and so forth. What I wanted, if I go back, I wanted the minimum number of turns. So I realized, now let's hold on and let's simply write what we have realized so far. We realized that we have this string which will have for sure length of 4. Every string will have a for sure length of 4. On every digit I will have 2 options. Either I will have a chance to turn it right, which means if I have a number, let's say 9, if I do a right turn, it will be a 0. For any other number, let's say 1, it will be a 2. For 2, it will be a 3. For 3, it will be a 4, and so on and so forth. So for all the other numbers, it will be just the next digit. Same way for left, I will have an option that, okay, if the number is 9, that's right, if the number is 0, if I turn it left, it will become a 9. For all the other numbers, okay, if it's a 4, it will become a 3. If it's a 5, it will become 4. If it's a 8, it will become a 7. So it's simply C minus 1. So if I ask you that if I give you one string, and if I ask you that what all 8 options, what all 8 strings you can generate, then you will simply say, Aryan, I know that you will give me strings. I have to find the next possible options, next possible strings. I know these are 8 strings, so I need to return a vector of strings. I will simply have my answer which will store all the 8 strings, and then I will go on and iterate on all the digits. I know it's a string of length 4, this will have 4 digits, so I will go on to all the digits. For this specific digit, either I can turn this to right or left. So for every digit, either I can turn right, or for this digit I can turn left. And then whatsoever string is generated, I will just push back that digit in my answer. Cool. And thus you can return the entire vector of strings, which is the next option from a specific string combination. Okay, so far you have reached to a point, but still you don't even know what algorithm to apply, how to even solve it. Okay, let's see how we will solve it. Okay, we realized a very basic fact that what we were doing, we were starting from 0 0 0 0. At the first turn, I will have, again, I have not shown all the options, but okay, I will have some options of strings. In the next turn, in the second turn, I will have again some option of strings. In the third turn, I will have again some option of strings. Now, in every turn, as I'm saying, I'll have some options of strings. I will make sure, and again, for me, these turns are important. These turns, basically, I can even say, for me, these levels are important. For me, these levels are actually the ones which are important. So I realized that, okay, for me, a turn is basically a next level of the graph, and whenever it comes down to be, okay, that I have to reach to a specific node, and that node is at a specific level, which means I need to reach to a level as fast as possible. So it is very obvious that you will do a level wise traversal in a graph. Okay, in a graph, okay, it's a simple level wise traversal which we wanted to do. Then we realized that, okay, we had nodes at this specific level. We had nodes at this specific level. So as soon as I was at the root node, I went on to all the possible eight nodes. Okay, which means these are the possible first. In the first turn, I can reach to all these nodes. Then at the second turn, from all these 8 nodes, I will again branch out all the other 8 nodes, and then, okay, it's the second turn, which are again the possible answers which I could have. Again, for the next third turn, I will again branch out 8 from all the above second turns ones. So you can see, I'm just trying to see, okay, at which level I can easily achieve my target. And as soon as I will see my target, I will simply say, bro, this is the earliest turn to reach my specific target, and for sure, earliest turn as in earliest level. So I was actually trying to go level, because for me, every turn is at every level. So I was going at every level, and every level I'm trying to find if I achieved my target or not. So I'm just traversing my entire thing level wise. So you know that level सबके निकलेंगे उसके जो खड़ा रहेगा, right? So if you had got so far, just smash like button. If not, then you can just simply see क्या हो रहा है क्या नहीं. Now, why I spoke Hindi, but yeah, no worries. Cool. So that is, we realize, okay, we will actually traverse level wise in the entire graph, and thus we can actually reach the earliest level at which I will see my target. And Aryan, what about these stuff? What about these stuff? These dead ends? Simple, bro. The same way, if you remember, the same way you have a visited array, which so that you don't visit that again. Same way I will have dead ends. Same way I will have dead ends, which will make sure that you don't visit again. As soon as you find a dead end, which means a string is inside my dead ends vector or unordered set, I will make sure, okay, I don't visit that string again. Cool. Now, a very basic fact, okay, Aryan, the flow which you told, by that it seems like that, okay, the graph BFS traversal is applied, but Aryan, why not simple DP? Bro, it's simply, DP actually helps us store the answer, right? I wanted to store, okay, for this specific node, if it would have been there, what could have been the answer? That would have been stored at the DP of this specific string. That is how DP helps us, which means storing the answer for a sub problem. Did I need it? No, I did not. I wanted that, okay, as I go on to any of these levels, as soon as I found a node, I am good. Even if I encounter a node, I'm not saying I will store the answer for the subproblem. I don't want that. I don't want to go on to its child again. I don't want to even know about its child again. I just want to know, okay, if it is encountered again, please skip it, because I wanted to just go on all the occurrences of the string. And for me, as soon as I get the occurrence, I'm saying, okay, I'm done, I'm good. So DP actually helps you to store the value for a specific subproblem. Here, I do not want to store any value. I just want to know, have I seen that or not? If yes, great, skip it. If not, then go on and try for it. So I just wanted to get to my target as soon as possible. I did not want it to store any problem, any sub problem. I did not want it to store any of the part of the problem. That's what not I required. That is the reason we got to know, okay, it looks like a tree structure which can have a repeating problem, but then we realize, okay, it's actually a level wise traversal, which means it's a simple BFS traversal. Now everything is so far done and done. It is simply a BFS traversal. Now let's look at the code. It's pretty simple, exactly same as what we saw. Firstly, I show you a very small components. As I showed also, we have a turn right which will turn every character to the right. We have a turn left which will turn the character to the left. Then we have the next options for a string. What are all the 8 possible next options, in which I told you I will iterate on all the possible characters, which means 4 digits, and then I can turn that right or left, and thus generating my answer vector. Now comes the actual main function, in which for sure I know it's a BFS traversal, for which we need a queue. So I will use a queue, and I also know that I have to make sure, okay, in a queue you make sure that things are visited once and not again and again. So what you will do, okay, you will keep track of the visited unordered set as you wanted. Then, as we simply know that we push the first node in the queue and mark that node as visited. Now I wanted to know the level as I go on to every level. As you know, as you go on to every level, you want to make sure, again, you want to make sure that, okay, which level it is, right? As you know that as I was going, this was level 0, level 1, level 2, and so on and so forth. Or you can also say turn. That's up to you how you want to name the variable, but yeah, it's a level wise traversal. So you will take that. One more thing, that you wanted to know that all these dead ends, if a string I find while traversing to every level, I will be iterating on all these strings. Maybe that string is actually one of the dead ends. Now, so as to figure that out, one way is you iterate on this entire dead ends vector and then see if that string is inside this vector or not. That will take O of, let's say this is D, its length is D, so it will take O of D time. And to be more precise, it will take O of D into 4 time, because each string is of length 4. So comparison will actually take O of length 4 time. So it's not good, right? Yeah, it is not. So whenever you want to do a comparison, right, so convert that vector to a unordered set. So I will convert that to an unordered set called as a dead end set. How it will help me? It will help me saying the earlier operation was taking O of D into 4 time. Now the operation will take O of 4 time only. Because I just have a string, I will search for the string in my dead end set. That searching will take O of 1 time, and for sure O of 1 time for one string. But one string is of length 4. So it will take actually O of 4 time, which earlier would have taken O of D into 4 time for one string search in the vector, where D is the length of this dead ends vector. Cool. So we have used a dead end set. Now I will tell you a bit improvisation in this dead end set, which is that you don't need the entire new set. You don't need that. You can simply iterate on all these elements and make sure that all these are visited. That is also so that you don't need it. But I put it purposely so that you understand what is happening in holistic view, because it will not reduce the complexity much, but still you will get the basic idea of how things are happening. Again, I'm showing you how you can improvise it, simply iterating on all the dead ends and marking them as already visited, because your queue makes sure that you don't visit each string again and again. Now a simple fact, while queue is not equal to 0, now whenever you want to traverse level wise, so we make the size of the current queue and then traverse on that specific size itself. Then, okay, the front of the queue, which is a string, I will make sure, okay, if that string is my target, then simply return the current level whatsoever I have. And for sure you can see, as my one level is done, I am actually increasing my level count by 1. Again, this is inside my while loop. As it is done, this level plus is outside the while loop, because it says one level is done. Now, if as you can simply see that if dead ends set, it contains the current string, so bro, continue. You cannot go on to its children. Bro, you cannot go on to its children. Please continue. And Aryan, what if this target is inside the dead end set? That will not be there, because questions have given that to us. Okay, then we go on to all the children's, which means for a string S, what are all the next 8 options? I will iterate on all the 8 options. If that option is already not visited, then I will simply push that in the queue and mark it as visited. And ultimately, I will simply get my level. If not, then I will simply return a -1. And that's how you solve it. Now comes the best part, which is the time complexity. Many people will not explain you that, because people know it's hard to explain. We will see that. We always see time complexity of every question. Now, it simply says that, okay, we are at a level. We'll go on to another level, but technically you might see, okay, Aryan, at every level I can see I have 8 options, so I can easily see, okay, 8 options, then 8, and so on and so forth. So at every level I will keep on going until my target, which means I have to see the entire length of the tree, or I should say the entire length of this entire graph. It's a tree, but yeah. Then at every level, I know it's 8 options, then 8 of all the children of the below ones, then 8, then 8. It might feel like it is 8 ratio of something big, which can be actually big, but I'll tell you, it is not. It is not the case. Why it is not the case? Because if you remembered, you easily saw one very basic thing. As soon as you were at the second level, you could easily see the things started repeating. And as soon as the things started repeating, you'll actually never go on to its children. So Aryan, then how will I get to know that how many nodes I'm actually traversing? It's simple. Just let me know what are all the possible options. What are all the possible different nodes that can be there in this entire tree? As simple as that. So we know the string is of 4 digits. At every digit, I have 10 possible options. 0 to 9, 0 to 9, 0 to 9, 0 to 9. So I know the different possible strings which can be there are 10 raised to the power 4 possible options. So in worst to worst case, you will iterate on 10 raised to the power 4 into 2 number of, again, these are distinct number of strings. In worst case, you can visit a string again, but as soon as you visit the string again, you will see, okay, it is already visited, and then you will skip it. So you realized in worst case, your BFS or your queue will actually visit these many different number of nodes. Thus, you would not be needing to iterate on the entire height and see, okay, 8 options, 8 options, 8 options, that you would not require, because you know there can be many repeating such nodes which you will not visit it again. So this is the different or maximum number of nodes which you will actually be visiting. So for sure, the time complexity will nothing be 10 raised to the power 4 into 2 for the worst case, and we know every string is of length 4, so each comparison will take 4. Again, 4 factor will for sure be added because it's a string comparison which is happening. As you can simply see here also that I am comparing this string S to target. This will take over 4 times. This operation will take over 4 times. So basically every string operation, because the string length is 4, will take over 4 times. And ultimately we realize that that will be the time complexity for us, which is 4 into 10 raised to the power 4 into 2. Now a bit here and there, the complexity, which means if, as you can see, you are building this, so again that's an addition factor which you can have at every level of building, but that is not the entire complexity, which means I will not multiply that by 8 specifically, because I'm actually building it while getting my entire tree. So it's the reason I told you what are different number of nodes you will be building. That is what your maximum complexity will determine. Okay. So time complexity is nothing but 4 into 10 raised to the power 4 into 2, which is much less than 1 second, which is good. What is the space complexity? Okay, for the space complexity, we realize that if you had already watched the video in which we have discussed the BFS traversal, you know that if I have a tree, again, I'm just taking the worst case. What is the worst case? Worst case is that I have no dead ends. I'm going on to all the nodes, and also in the worst case, my target is actually at the last level. Whatsoever is the last possible level, my target is at that specific level. Now I'm asking you, what is the space? Usually in a BFS, you know, the space will be used by a queue, and queue will use a space. What is that space of basically what is the number of nodes at a specific level? So to know the space in a BFS time or in a BFS algorithm, I specifically need to know what is the maximum number of nodes at a specific level. Now in a worst to worst case, what can be there? If I tell you there is a tree with n nodes, then we have seen that we can have n by 2 number of leaf nodes. So I realized, okay, if I have n nodes, I can have at max n by 2 number of leaf nodes, which means at a specific level, I can have at max n by 2 number of nodes or elements or strings. So I realized my queue, a specific level can hold, can again say O of n time, O of n space strings. And for sure we know that n is actually 1e4. Again, it's n by 2, but yeah, roughly I can say O of n. So I can easily say my space will be taken O of n by 2, and for sure we know that every string will take a space of O of 4. So that will be O of n by 2 into 4, which is roughly O of n into 2 space. But again, extra factors for unordered set will be added, which means plus d, and again for visited plus n. So this all that stuff will also be added. Again, this itself will make sure that you are going on to all the possible strings. This visited, again, as you know, that visited will actually have to store all the nodes. So visited will itself be O of n, which is nothing but 10 to the power 4, 10 to the power 4 into 4. Because I realized maximum number of strings I can make are 10 to the power 4, and each string is of length 4. So this is the space maximum used in the entire algorithm. So space used will be 10 raised to the power 4 into 4. And time also is 10 to the power 4 into 4 into 2 again. This is up and down, which means plus d plus n plus again. But this is the main bottleneck of the entire problem. And that's how you solve it. Cool. I hope you guys got it, like it. If yes, then please do smash the like button. It helps a lot. Again, it feels like big manga, but yeah, because people don't watch it. It feels a bit pain even after telling everything. We don't get stuff. But again, if you have any improvements, any stuff, you can just let me know. That will be helpful. We will implement it. Bye bye. And else, bye bye. Take care. Goodbye.